Welcome back everyone to the Hello World Guide. This is another episode of the OpenGL Tutorial Series, and in this video we are going to do two major things. The first thing that we'll learn is adding new attributes to our vertex array object and seeing how we can use those attributes in the shader and pass them from one stage to another. And more specifically, we are going to add a color attribute. We'll also see how interpolation works for attributes or for values that we pass from shader to shader. And the second thing that we are going to do is understand what an index buffer is and where it's used. So let's go ahead and get started with adding the new attribute. So here you can see that where we are creating our vertex data, currently it only has a position. Now imagine we want to add a color to this so that each vertex has its own color. So we can do that right ahead of it, and we can just say, currently of course we are just using a raw float array. We should use a type for this in a more complex setup, but for now it is enough. So for the top vertex we are going to use RGB values for red, green and blue components of the color. So we are going to do 1, 0 and 0 here for the first vertex, and this is going to represent our red color. Then we are going to do similarly here for the green color for the second vertex, and after that for the third and the final vertex we can also similarly do like a blue color. So we have the complete RGB color here. So we have set up our vertex data like this, and now we are going to address change our vertex array object to actually reflect that so that the bindings and the attributes are correct. So you can see that here we set up the vertex array, and after that we set up our first attribute, which has binding index of 0, and we set its size and its type, and we set it to be normalized to false, etc, etc. Now before we add a new attribute, you can see in the vertex array vertex buffer command we are setting the stripe to be 2 multiplied by the size of float. Now we want to actually not do that, because of course now we have 5 floats per vertex, 3 for the color and 2 for the position, so we can change that to 5. And now to add a second attribute we are going to just copy and paste this here, and the second attribute we are going to just change its index to be 1, but the binding index is going to remain 0 because it is in the same vertex buffer that is bound to binding index 0. And we could put this in actually a separate vertex buffer object that is known as like we could have, for example, a separate buffer for position, separate for color. That would also work, and we could set it up that way as well. But generally if you are rendering, it's better to have interleaved vertex buffers, which means that all of the attributes of the vertex are together. That makes it more cache friendly to accessing when we are doing the inside of our vertex shader, etc. So here when we are doing we are basically going to change the index to 1 on all of these 3 commands, and for the size of this when we are setting up the format we need to change the size to 3, which is because now it's actually 3 floats. And now we also need to change the relative offset. Earlier we had 0, now we need to change this to 2 multiplied by the size of float, since 2 floats are the position, and then we need to change it so that it actually has because our color is located after 2 floats after the position. So yeah, that's going to set up our second binding, etc. And if I go ahead and actually run this right now, what you can see is that nothing changes, which is because we are not actually using this binding, so actually nothing happens, but we still get a triangle, which means our data is not messed up, it's correct. So here to actually use this we can just go ahead and add another one of these here, and we can set the location to 1 here, and we are taking in an vec3 now, and we can call this a color. Now this color we of course don't want to use in the vertex shader, we want to use it in the fragment shader because that's what outputting the color. So we need to pass data from our vertex shader to our fragment shader. To do that we can use an out declaration like this. So we can say an out vec4 or vec3, we can just say vec3, and we can call this color here. And an important thing that we need to understand here is that one way to do these attributes is that you can just have a same name. So if the name of this matches with the name in the fragment shader, when we take it in, then it will be considered the same thing. But that is an old way, and while it's still valid to use, a much better way is to specify a location for this specifically, so that we can access it by index, which is a bit more reliable. So we can go ahead and, for example, call this out color to reflect its role in the vertex shader instead of calling it just color. And here we can go ahead and set our out color is equal to a color, just like that. We don't actually need to do anything else here. And in the fragment we can do layout location is equal to 0, and this is representing the thing that we are taking in input from the vertex shader. So we can take a vec3 here and we can call this color. The name can be different here, which is because we are using indices. If we were not using these locations, then we'll need to have the name to be matching. And here for the fragment color, we are going to now set it to our color. We are going to construct a vector 4 from a vector 3, so our color is a vector 3, but since it's a vector 4, the frag color, we need to specify an additional alpha parameter, which is going to be 1. So if I go ahead and run this, before we run this, another thing you need to understand is that as you know, the vertex shader will be run for each vertex, but the fragment shader will be run for each fragment. What that means is that of course there will be a lot more fragment shader invocations than vertex shader invocations. So at the exact point of a vertex, we'll obviously get the same color as the vertex, but any points between that, it will be interpolated. So that means that we'll get an in-between color depending on how far we are between, etc. and other things. So you can change this by using the flat output parameter, which means that everything will have the same basically attribute, but of course we are using this like this, which means it's going to get interpolated, and that means that this RGB that we have got, it's actually going to create a triangle which has all of the colors. So the top corner is red, and then bottom left is green, and the bottom right is blue, and between them we are going to get all of the colors which are combinations of these three. So if I go ahead and actually run that, you can see we get our color triangle here, and you can see it looks quite nice. So we have red here, we have green here, we have blue here. In the perfect middle we have kind of white, and between these we have in between colors like yellow here, pink here, and etc. So you can see that this is working quite nicely. So now let's move on to the index buffer part, and to help you understand why an index buffer is used and what its purpose is, let's consider a small example. So currently we are drawing a triangle, and let's consider that we want to draw a rectangle instead. Now a rectangle of course has 4 vertices, but we know that OpenGL requires everything to be rendered as triangles. It also has support for lines and points, but basically we cannot render like a rectangle or a polygon. If we want to render anything more complex than a triangle, we have to make it up of many different triangles, and we have to render those. So a rectangle can be represented by 2 triangles, so we are going to do that here, and I'm going to just go ahead and change this top to be top left because we don't want it at the center anymore. We are going to duplicate that, and I'm going to change this to be top right. So the first half, or the first triangle of the rectangle, is going to be the top left, and bottom right, and then the second one is going to be the top left, top right, and bottom right. So for this we are going to go ahead and change this to be positive, of course, and this is also going to be positive. It's not the bottom anymore, the y coordinate needs to be positive. And for the color of the top right, let's just set that to white, and yeah, that's pretty much it, and this should set our vertex data up correctly. Of course, when we are rendering it, we actually need to draw 6 vertices. So if I go ahead and run that, you can see that we get our rectangle onto the screen. Now this of course works, but there is a problem with this approach. As you can see, we are duplicating our bottom right and our top left vertices, so we only need 4 vertices, but we have 2 extra vertices which are duplicated, and that's like a 50% extra memory cost, and this is not very efficient. And for large models that contains many different complex shapes, this can actually get quite costly. We'll have many duplicated vertices, and that won't be very nice. So what is the solution to this approach? Well, in order to actually solve this approach, the solution is an index buffer. So instead of rendering our vertices directly, we render them through an array of indices. So we first of all define all of our unique vertices. We will not repeat any vertices, we will define each of them as unique. So we'll take each of our unique vertices, and then we'll have another buffer which is the index buffer, and each value of this buffer will be an index into that vertex data that we had. So for example, 0 will represent the first vertex, etc, etc. And then we can in our index buffer, we can, if we want to render the same vertex twice in different triangles, we can specify that in our index buffer. So to get an example of this, we are going to create an index buffer. We are going to just make it a uint32, and we are going to call it index data. And here you can see we have got in our vertex data, we have basically got 4 unique vertices: top left, bottom right, and top right. So let's go ahead and we want to render 2 triangles, of course, so we are going to specify in our index data the 2 triangles that we want to render. So the first one is going to be 0, which is the first vertex. Then we are going to have 1 and 2, and then we want to draw the top left, which again is 0. Then we want to draw the top right, which is this is going to be 3, and then we want to draw again the bottom right, which again is 2, and we can remove the bottom right and top left redundant declarations from here. And as you can see, now we have an index data which consists of 6 indices, which are indices into this buffer, which specify which vertices in which order we want to be drawn. And this, as you can see, just contains all of the vertices which are unique. It does not contain any duplicate vertices. Now how are we actually going to use this? For that, we are going to have to create another buffer. So we are going to create a buffer called EBO, and in OpenGL terminology it's not called an index buffer, it's actually called an element buffer. So EBO for element buffer object, and we can do gl create buffers, and we can create our element buffer object, and then we can do gl name buffer storage, similar to how we did earlier, and we can give our index data this time in here. So we basically upload our index data. Alright, so at the end we are going to go ahead and where we are deleting our vertex arrays and the buffers, we are also going to delete the index buffer. Alright, or the element buffer. So now to actually use that in our vertex array object, it's quite simple. Just like vertex array vertex buffer, we can do gl vertex array element buffer, and we can specify our VAO, and we can specify the buffer that we want to use for the indices, and that works. And to actually render this, we will not use the gl draw arrays, instead we'll use the gl draw elements, and we can give it our mode, which is going to be of course gl triangles. Then for the count, this is the amount of indices we need to draw, that's, or the elements we need to draw, we are going to say 6. For the type, this is the type of each element in our index buffer array, and since it's doing 32, we are going to say gl unsigned int here. And after that, we have got, this is an array which you could use also to specify indices directly here, but if you are using an element buffer object, this can represent an offset in that, but currently we just want to start at the beginning, so we can pass null here. Alright, so if I go ahead and actually run that, you can see we get the same result, and this is because now we are using our index buffer. So 0 means this is being drawn, then this is being drawn, then this, and for the second triangle we have 0, and then we have 3, and then we have 2. So this essentially means that we have got our index rendering working, and as you can see, our vertex data is not duplicated anymore. Instead we have the index data, which is making it quite easy. And in large models this can actually matter a lot, because if we were duplicating all of the vertices, we'd end up with a lot more data than we should. So anyways guys, this is going to be pretty much it for this video. I'll see you in the next one, in which we are going to dive deeper into uniforms and how we can pass input to our shaders. So make sure to like and subscribe and stay tuned for that, and share this video with other people as well, and bye.